Good afternoon to all of you. So, our next speaker have joined. I'm going to introduce about him. Dr. Suraj is currently serving as an assistant professor in the Department of Electronics and Communication Engineering at IIIT Bhagalpur, India. He obtained his ME and PhD from BIT Misra Ranchi and completed his BTech from BPUT Raulkela. Prior to joining IIIT Bhagalpur, he served as ad hoc faculty at NIT Calicut and SBNIT Surat, and also possesses industry experience with Infosys Limited. His research interests include neural network, fuzzy logic, biomedical signal processing and control, IoT and embedded system. Dr. Suraj has actively contributed as an author and reviewer in reputed international journals including IEEE journals and biomedical signal processing and control. His work primarily focused on the application of intelligent computational technique to real-world engineering and healthcare problems. Thank you, sir. Over to you, sir. Please, you may proceed it.
Thank you, sir. First of all, I congratulate you for conducting such a inciting STTP, and then I thank Professor Madhusudan sir also for allowing to conduct this particular STTP. So in this particular STTP, like I'll be focusing on computational intelligence technique for biomedical and agriculture application. So content of this particular presentation will include introduction. Introduction, it means I'll be introducing what this computational intelligence is. Then obviously in this particular case, basically we'll be focusing on signal. So here, whether we use the signal for biomedical area or for your agriculture area. So that would be a signal. And then we'll be applying some techniques. So there are obviously here in this particular case, basically what we do is we go for classification. So for classification, we need feature. So obviously we need to deal your feature selection. And then obviously after feature selection only, we can go for classification. Now, first, we need to know what this computational intelligence is. We understand what is computational. Like we want to compute something. If you want to compute 2 plus 2, you don't require intelligent technique. You require some mathematical technique. That's it. But there could be a question you people must have faced, like your maternal uncle holding poppins in his hand will ask you, like, whom do you love most, father or mother? I don't know whether you people have faced this problem. I have faced this problem. And then what is the motivation? Motivation to answer this question is poppins in his hand. Now obviously in this particular case, this is a difficult question. You cannot say like who loves you most. Now in this particular case, obviously we need to answer. Now in your age, you might have faced this problem, or maybe your beloved have faced this problem by you, how much you love me. I faced this question in class 3, myself holding ice cream. Now in this particular case, what to answer? Any answer you'll give, it is likely to be wrong. So in this particular case, obviously we need some intelligent technique, we need some smart technique. So screen is shared, I guess. That is shared. Anyway, so in this particular case, what we need to do is we need to use, how can we quantify this particular thing? Do we have any technique? Why this problem is like difficult to answer? The reason being, these are real-time problem and these are uncertain. These are complex in nature. So obviously in this particular case, we need some smart way to calculate, smart way to quantify it. So obviously in this particular case, what we'll do is we'll try to imitate how human or any living beings answers or they act upon. So in this particular case, what we have is like we need to understand in mimicking your human behavior. So how do we learn? How do we behave? And at the same time, how do we quantify this type of answer? So here The answer comes from your like certain things can be adaptive also. Like if you take example of your resistance, if you say what would be the value of voltage, so obviously in this particular case, if you'll measure it, it may not be the same value that you'll be finding theoretically. What could be the possible reason? The possible reason could be the resistance will change. The resistance will change because of heat, because of temperature. You people, you and there what you are doing is you are trying to use your Ohm's law. So obviously in this particular case it will fail. So you people must have studied that we go for modeling anything that we want to represent, anything that we want to analyze, anything that we like control. In that particular case we need to go for modeling. And when we go for modeling, what exactly we do? We convert your physical phenomena into some mathematical expression. How to do that? Obviously in that particular case we make certain assumptions. And when we make certain, like we people know that certain assumptions are there, like things are not going to be ideal. So obviously in this particular case your computational intelligence will come into the picture. So what exactly, if I pinch this student, if I pinch this guy, he's smiling. If I pinch harder, he will smile more. And the next time if I pinch more harder, in that particular case he may thrash. It means behavior may not be linear one. So these are the basic problem. To resolve it, we need some smart way, we need some intelligent way of computing this thing. We cannot compute using some mathematical equation. This cannot be computed. So obviously in this particular case what we do is we get inspired by nature, how ant work. It means using, and from there we have your ant colony optimization, you have swarm optimization. We learn from adapting. Like in this particular case, suppose when you enter into a room which doesn't have that illuminance, so in that particular case your eyes will expand. So it adopt, or doing that particular thing, it will let more light to come into it. It means what? We are going for some adaptation. So we need to have some natural adaptation. So solving your uncertainty, solving your uncertain problem, so obviously we need some smart way, we need something which cannot be answered by your general, by your technique which are listed in mathematics, in general mathematics. So the major component of it, like we mentioned that we will try to imitate your human behavior, we'll try to uh, uh, copy how your machine learns. We know how human learns, so we want now what is the next? The next is we want how machine will learn. We want your machine to learn. We want your machine to imitate your human behavior. So in this particular case, one like important pillar of your computational intelligence being your artificial neural network. Then your fuzzy logic system, like when we many time you people are asked to measure something, you came out with a solution, say 1.01 meter. Another student may come up with some other value, say 1.0123. Another student may come up with some other solution. So likewise, now in this particular case, one which is more precise may think that will be more correct. It may not be the case. Imperfection is the new perfection. So in this particular case what we have is, like, we can use something which is where we have some ambiguity which is not clear. Like if I ask whether you are boy or you are girl, in this particular case your answer would be a very definite one. Either you'll answer your boy or you'll be answering that you are girl. But Lofty Jade answered it in a different way, and that's why he like initially he was called mad. But the same theory we are using, which is making your artificial intelligence possible, which is making your chat GPT work. So another being your fuzzy logic. The name itself suggests something which is where we have ambiguity. So we'll try to model, we'll try to look at how your ambiguity, how your impreciseness will give you perfectness. Another being evolutionary computing. Obviously, in this particular case, we'll be dealing your optimization basically. So your swarm intelligence and other things are there. Now, first I'll come to your fuzzy logic system, which is introduced by Lofty Jade. So I won't go much more in your like what you call theoretical part. Let us simply fudgification. So in this particular case, when we say fudgification, so we people already learned. You must be knowing that here we have a crisp theory, another being your fudgy theory. So fudgy theory here. Let me. So one being your fudgy that we are going to deal today, and another being that you people are already acquainted, your crisp logic. So crisp logic is your real time numbers, like either anything would be 0 or it would be 1. What I mean to say is, if you ask what is the color of this, so you may answer a definite answer. Now ask the same thing from a girl. In that particular case, she may come out with n number of answers. Do not take me a gender bias. This is very much correct. This is technically correct. In this particular case, if you are asked to buy something of red color, in that particular, you might have faced this particular problem. Like in that particular case, your sister, your fiancé, or your wife will tell you, like, the color is not something that she had asked to buy a particular thing, say a lipstick or anything. Now in this particular, it means what? We may have n number of shades. We may have n number of shades in a particular color as well. Now in this particular case, like in real time scenario, we face certain problem which cannot be solved with a very definite answer. Let us take example of a braking system. Like you want a brake to be applied automatically. Now in this particular case, if there is a vehicle and we have another vehicle at a particular distance, and you make a rule that if the distance is this much, then only your brake should be applied. Now in this particular case, like in general scenario, there could be a case that the distance, instead of being this one, it can be this one, like at a moment, whereas here at a particular moment it could be this one. Like this is just a fraction of difference. So how to consider these type of problem? Like if you try to apply the brake like instantly, in that particular case your vehicle will topple. So obviously in this particular case, if you use or if you make use of your fuzzy logic, like your speed regulation would be better and your vehicle stability would be more. So this is being used in lot many like ADAS system where a brake need to be applied with a logic. Now in this particular case, we do not measure a very certain value. Here in this particular case, what you will be using is, you'll be using some sensors. You have some sensors, you are getting your distance information, and then you have got a logic. Now if you apply a crisp logic, in this particular case the decision would be either 0 or 1, whereas you may require, or rather it is required, that you have to take decision in between. So in this particular case, what we have, like when we make decision, it depends on n number of variable. Now in that particular case, if your variable increases and at the same time your condition also increases, so do we have any method which can take account of it? Obviously we have fudgification, a method, like using your fuzzy logic, a method that will help it. So what the fudgification is, so you can see your crisp quantities are getting converted into your fudgy. Now your fudgy, it means what? So we are getting some membership value, the degree of association, something like whether this pen is of red color. So obviously in this particular case, you may answer it is not of red color, rather it is of white color. Some may answer a bit of it, it is red color, the bit of it is a blue color. So likewise, so in this particular case, what is the degree of association? So what is the degree of association that is called membership function, which is denoted in this way. Now here in this particular case, like what is the degree of association of a particular color being red or white or green? So here we won't eliminate all the values, all the rather we'll have the possibilities of one color being or being represented as another color as well. Now what is that degree? What is that association? That is called membership function. So here in this particular case, your membership function include in between 0 and 1. Instead of just 1 and 0, here we will be including a different sets. So here are different degrees. So the degrees will vary from 0 to 1, including your 0 and 1 as well. So when we use 0 and 1, in that particular case, it is crisp logic at all. So in general cases, like we try to have a value in between 0 and 1 only. Now, what are the methods that we have? Now, we get to know that fudgification is to be done. Right? What are the methods for fudgification we have? So one being your intuition, your own feeling with a problem. So these are the methods. People, if you are noting down, you may note down. So in this particular case, the very first one being your intuition. Intuition is very easy method, but is still very important and widely used. Like what you feel. This is used in gambling. Whether a particular country will win a match, so it depends on, like you people go on betting for it. So obviously in this particular case, you have some prior information. You have some knowledge. You are expert of that particular case. You use your exposure, you use your expertise to solve it. Now, in this particular case, what we have, like when you use your exposure and expertise of a particular thing, your know and how with a particular thing, and you assign some membership function, so that is called your intuition method. So this is what it is written over here. You people may just go through it. Intuition is based on humans' own intelligence, your own feeling. You feel that like you need to carry umbrella, it may rain. So in that particular case, obviously you are familiar with your weather condition, and then you determine whether it is going to rain or not. So what is the degree of association, like having a chance of getting a rain? So your own expertise, your own knowledge. So when we use it, so in that particular case, that is called your intuition. Here we have one such example where speed is used in one as one variable, and another we are trying to quantify it. We are trying to categorize under certain categories. So here, so this is called linguistic variable. Your low, your medium, your high. These value, like your speed value. So in this particular case, speed is represented in your RPM. Your speed, your different speed. Those who are from mechatronics department can understand better, or even any department. So in this particular case, what we have, like we have certain speed ranging from 0 to 2000 RPM. So what we have done, we have categorized this speed as low, medium, and high. Now we have ranges of speed which is being categorized as low. Now in that particular case, say here we have some value 5 RPM. Now 5 RPM being categorized as a low speed. So obviously in this particular case, your membership function is high. Here in this particular case, the example that we have taken, it comes out to be 1. Now if we take another value, say here, say 300. Now 300, this particular value being categorized under low speed is lesser than 1, say 0.8 or 0.9. Now we may have some other values. Let us consider this value 600 RPM. Now this 600 RPM will get categorized under your medium speed, and at the same time your low speed as well. Now if you make a decision, if your speed is medium, in that particular case you are going to do something. Now obviously in this particular case, your decision would be 2. You need to have, like it would be in dual mode. You need to have a 2 consideration. The same speed is lying under low speed, and at the same time same speed is lying under your medium speed. Now obviously in this particular case, your membership functions are different. So obviously when you make rule, so your rule would be more, or what you can say that you're considering lot many cases. So here we have ambiguity whether a particular speed need to be categorized as a low speed or a high speed. Now with the help of this, like this particular thing uh, uh, will like using this ambiguity will empower our controller to take a better decision, a better result therefore. So likewise here we have, like there could be one speed, say this one, it can be something around 900 rpm. In this particular case it is being categorized as the low speed, and at the same time it can be categorized as a medium, and at the same time it can be categorized as a high speed as well. So what it gives, it powers you to use lot many consideration. It means we are not eliminating any case, rather we are considering each and everything. So your fuzzy logic allows that. So this is one method that we use, and that is your intuition. Another being your inference. So in this particular case what we have, like we require some mathematical foundation for it. We will be deducing with the help of some standard mathematical formula. Now I don't know whether you people face or you people have faced this problem or not. In my case I have faced this problem, which is another reason for motivation explaining this particular topic. In class 3 I was asked, everything happens with me in class 3 only, because I studied class 3 thrice. Now I was asked to draw equilateral triangle, and I came out with this type of triangle. Here the value being 60 degree, here the value being 59 degree, and the value being 61 degree. Now if you are teacher, how much marks will you give? Pradeep, how much marks will you give? I'm asked to draw equilateral triangle, and I came out with this answer. Chandanji,
96.
96. So Chandanji will give me 96 out of 5.
नहीं आप 96% बोल रहे थे ना.
Okay. Anyway, he will give some marks close to 4.5 or something out of 5. Now Pradeep will give me 0 marks. Getting it? But when I'll correct his copy, he will say, so there is a slight mistake only. This is the slight mistake only. So instead of deducting the full marks, you should give a partial mark. So that is the case with fuzzy logic here. When you argue with your teacher, so that gives, or like that is the basis for your fuzzy logic. So in this particular case, everything is considered. There's a difference of just 1 degree. So I get 0. A mathematics teacher may give 0. I don't know. But this topic belongs to mathematics domain only.
Sir, because of this, there are many random noise will occur.
There would be random noise. Okay. So where we have a voice, there will have a noise. So like you'll say, a lot many students will say, like instead of like 4.5, you should give 4.25, or say 4.7, or maybe 5 at all. Do you mean to say this? This is not perfect, I've already mentioned, but imperfection is the new perfection, or imprecise data or imprecise decisions like become a basis for taking some precise or very accurate, or maybe to solve, or like it will empower you to solve a very complex problem which cannot be solved otherwise. Getting it? Now in this particular case here we have, or we are introducing one method which is your inference method. Getting it?
Yes.
So you won't be getting 0, like, but I had got 0. I myself, I mentioned in class 3, I got 0 for this. The reason being, for equilateral triangle, your all angle need to be 60 degrees.
My answer is right, sir.
You are right. You are always right.
Yes, thank you, sir.
You don't need to be right. For fuzzy logic, if you're always right, then there is a problem. Anyway, so you people can note down what exactly the inference is. So this method involves the knowledge. क्या हुआ जी इसको? Marketers. So this method involves the knowledge to perform deductive reasoning. It means in the last case, we don't have a very standard way to find or associate a membership function. It all depends on your intuition, what you feel. Now, in this particular case, we have a rule, we have a way. So all students will have the same value, even though we have imprecision, even though, like you mentioned, like there would be noise. It means there would be like a student will be quarreling, or student will put question that why I'm getting a particular marks, whereas another student, like impartiality is being done. You know, now to solve it, your inference will solve this particular thing, and that's why we have this method. But this method cannot be applied to all the problems. We already mentioned where to use your fuzzy logic, where to use your logarithmic. ऐसा नहीं है कि 9 का क्यूब के लिए आप log table देख रहे हैं. Obviously, like you'll be looking for complex problem. We already mentioned that these computational technique need to be used for complex problem only. Obviously, here in this particular case, we are using a problem which should be understood well. So I'm using something which is very much clear, but it's still in, like when you are using your computational technique, your computational method, it should not be used. Something can be solved very easily with existing well-defined methods. So here what we have, like we have taken example of your triangle. So in this particular case, we may have n number of things. Like instead of calling it isosceles, instead of calling it say equilateral triangle, we are calling it appropriate isosceles triangle. It means what? We are putting this, like here with the help of this, I want to introduce the notation, like how your fuzzy quantity are being represented. Like if I write A, it would be a crisp set, simple. No, so what we do is we put a tiddle sign. This is the way, this is a notation. So in this particular case, when we put tiddle, so it denotes that this is your fuzzy quantity. Getting it? No. So one other way we are learning like representation. I can see like my lecture or my explanation all changes as per your input and mood, and it will change. So I can see there are a lot many students who must be interested or they're taking interest. So I'll go for notations also. So in this particular case, like how this is notated, like denoted. Now in this particular case, it can be written as say 1/5. No, it is not 1/5. This is called delimiter. So here, this is your membership function, say 0.5. So what is 5? So 5 being a member of class A. This is how it is denoted. Getting it?
Yes.
So if I write 6 here, 0.2, if I write say 3.4, if I write say 7.3, anything. Just so in this particular case, this is your association, degree of association. So what exactly it mean? It mean 5 being a class of A, 5 being classified as A. So A being your linguistic variable there, and 5 your element there. So what is the degree of association? So that degree of association, what is that membership function? So that membership function is 0.1, 0.2, 0.4, and 0.3 in this particular case. So here we have a different element which is being considered for your set A. Now this set A is being taken as your fuzzy set as A. Now in case of your crisp logic, the same thing cannot be present at two locations. Either it would be or it won't be. So there we have lot many things that cannot be covered in just one class or in just in one presentation, but still I'll try to cover something which is important, something which with the help of that you can feel that you have a basic know-how of a particular thing. Now in this particular case, you people can, or rather you people are taking interest, so let us solve for this particular problem. Like here we have a triangle. So in this particular case, what we have, like let us consider isosceles triangle, or better to say appropriate isosceles triangle. Now what is the mathematical foundation here we have? Here we have, like, if this is angle A, this is angle B, this is angle C. So in this particular case, A plus B plus C will be equal to 180. This is fixed.
Yes.
This is fixed. The sum of the angle of a triangle is 180. This is fixed. Now, obviously, you like to implement using some coding. So in this particular case, if we make your angle A is equal to or greater than B is equal to greater than C is equal to greater than 0, we can have this condition. So what we can do is, like, we can arrange the angle so that when you go for coding, like the steps would be lesser. For this reason only, like, we'll arrange the values such that your A is greater than or equal to B, B is equal to or greater than C. It means it is arranged in your decreasing order. If I say A, B, and C are the order. So I want you people to find the membership function if the values of a triangle are, say, this need to be 45 degree, 45 degree, and this need to be 90 degree. It can be like this can be one example. Now instead of this value, say this value is 46 and this value is 44. So I want you people to compute what would be the degree of association, being categorizing this as your isosceles triangle. You understand, this is not isosceles, but if I say this is fuzzy isosceles triangle, or in case of like marking, how much marks will you award? You people may compute and let me know like what formula you use. This one topic only can cover your neural network also. Like later on we'll find like neural network being method for getting your membership function. It means fudgifying the things. So this will cover your neural network as well. So like those who join let, for them let me share this particular thing. ये पूरा गंदा हो गया है, 2-3 साल से ये यूज कर रहे हैं, but anyway, but the handwriting is good, that's why I'm using this sheet. Your solution is also given here. See, in this particular case, you check if you agree with this solution. Why? Yes, sir. You should not agree with the solution. Can we have this as one possible solution? See, in case of your isosceles triangle, so two angles should be same. The value should be same. Getting it? So in this particular case, what we have done, we are finding the difference. The difference would be 0. If it is not 0 or it deviates from there, so obviously your membership function will go on decreasing. Getting it? So what we have done, like the maximum value can be 1. From there we are deducting some value. So there we have 1 minus. Now in this particular case, we have minimum of A minus B or B minus C. We don't have A minus C here. Why? The reason being, we have already considered the sequence of angle of triangle being A is greater than or equal to B, B is greater than equal to C. So obviously, we want to have the closest one for isosceles, something being isosceles. So what is the deviation of it? What is deviation from it? So in this particular case, anything, say A and B, we can have B and C. So likewise, in this particular case, we'll be selecting the minimum of these. Getting it?
In this case, why we are dividing?
Divide. This is
factor of
called.
60?
I'll explain this. This is what I want you people to answer. Getting it? So what could be the maximum deviation? It's like normalization. Though I haven't explained it, but this is well understood. Obviously, in this particular case, we need a normalization factor. What would be the maximum value? What would be the maximum deviation? Now, in this particular case, if we considered your acute triangle, so none of the angle would be greater than 90 degree. So what would be the maximum deviation you can think of? Here you'll have a concept of optimization. Like you people must have used your dx by dt and all. So there, like we have, from there you can find like what would be the maximum deviation, what could be the maximum difference in this particular case. So here in this particular case, obviously your any isosceles triangle would be equilateral triangle as well. So from there itself, I explained this particular example. So it connects with that. Your all isosceles triangle are equilateral triangle also. So there you can see what is that difference, what difference you may have, what maximum value you may have. So in this particular case, if you divide it with 60 degree, it will get normalized. Getting it? And then you'll find the value. So please do compute the problem which was assigned. You can find like for the given problem. So here, what exactly we do is like we write program, and the moment you'll get the values, so automatically you'll get the membership function. Now, when you use it fuzzy logic, so obviously like each time you're not going to compute, you'll have some code written which in turn will imitate or which in turn will behave the way you want. Or take another example being isosceles right triangle. This being a very simplest one. So the value should be 90 degree. Now in this particular case, if you consider acute right angle triangle, obviously your triangle like your angle A need to be checked. You need to check your angle, A. You'll be checking A. What is the deviation of A with 90 degree? That's it. So from there you can solve the problem. Now here the things get extended. We have the another thing which was written over here is your other triangle. It means what? None of these. Or we can have a right angle at the same time isosceles also. So both the cases. So you understand different things. De Morgan's law you must be acquainted with. So using those things, these type of problem can be solved. Here it follows the same properties. No, it means I'm trying to come to properties as well. So I'm not going to deal those things in much more detail. But what I want to explain is what is the law that it doesn't follows. Doesn't follows like here in this particular case, if you'll take A and another one, if you take union of with your A bar. So in general, like with your crisp logic, what value you'll be having? You'll be having 1. Now, if we take intersection, you'll have
0.
0. You'll have null.
Yes.
Getting it?
5.
This doesn't follows with your fuzzy logic. You can check it. The same thing like what we can have is like in case of your crisp logic, first we check it would be something like this. So let me change the color with another one. So this would be high. So here we have high. So here we have a 0. Getting it? So that completes it, the whole universe. the whole universe. Whereas in case of your fuzzy logic, so in this particular case, it can be this way. Getting it? So in this particular case, like the we may not have the whole universe. We may not have the whole universe, and at the same time, we may have something which is common. So your this doesn't follows your middle excluded law. This is called middle excluded law. Something very important I wanted you people to know. So there are other methods as well. I'm not going to bore you people with just one topic. So other being your rank ordering, angular fuzzy set, neural. These are not like limited methods. We have lot many methods. These are just standard methods. Okay? These are the basic standard method. One being your neural networks as well. You can use neural network also to get your membership function. Then we have genetic algorithm, which is already a topic for your evolutionary techniques. Then we have inductive reasoning. Many of you might have studied in one or other subject of machine learning. Now, let me get back to the slides again. क्या हो गया जी? No issues. Okay. No, this is not the one. कोई बात नहीं समझ में आएगा तो फिर से डाउनलोड करके करेंगे. So we people dealt this thing like here we are trying to mimic the human decision making or the human thinks. Yeah. When you say fuzzy, so nothing is taken, like we are not discarding anything. We have possibility of each and every variable, each and every possibilities, and we are using your linguistic reasoning. We're not going for say 5. How much do you love me? Yes, 5 out of 7. No, we answer it in like qualitative way. So these things like I've already dealt. Then we have your journey of neural network. So I'll be dealing this thing again. So here like the characteristic of CI technique. So we have already seen what is the characteristic of it. Adaptivity. It means a particular parameter should be able to change. Learning ability, like when we have a neural network, of course, when we are using, so there will have your learning capabilities. So this learning capabilities will be having from your neural network. Then we have your fault tolerance, like the example that we have considered for resistance and all. So likewise, and which in turn will give you robustness. Advantages of CI. So here we can handle your uncertainty, learns from data as well. So we have already like your optimization technique when we use it, and then learning. So obviously it will learn from those things. Let me simply let me come to a particular problem. So here we have pattern recognition that I already dealt. We want to use this technique for some application. So as per this STTP is concerned, so here we are focusing on biomedical signal processing or biomedical engineering. Basically it is mentioned, and then another being your agriculture. So in both the cases, what we have, what is the similarity? The similarity is eat better food. That is connected with your agriculture. That's not the case here. Here we have enormous amount of data. We need to analyze lot many data. So obviously we need to have your deep learning. It means what? We have your back propagation, like those who are acquainted. There itself, if you'll go on incrementing your layers, your hidden layers, so in that particular case, it will become your deep learning. I'll touch those things. Just let me first complete these topics. So mainly, or basically all these area, this make use of classification. You'll classify whether something has a disease. Some, if you have some crop, in that particular case, whether this crop quality is this much. So what you are doing, you're trying to classify it. So basically we'll be using your pattern recognition. Now first we are dealing with your biomedical signal. So why this biomedical signal is different than other signal? What makes it different? Signal are signals. Why we are learning in a different bracket? So we people know that whenever we acquire signal, we require some transducer you will have, some sensors you will have. So obviously in this particular case, what we are trying to do is convert one form of energy into another that can be measured. So obviously in this particular case, like if you are using sensors, so there you like to convert it into voltages or current. I mean to say your electrical quantity. It can be capacitance as well. So here we have different energy. Instead of calling a particular signal, let us look at your with your energy associated. So there you can see your chemical. So there your blood ion, pH. We can have a pH value. This will justify for your agricultural need as well. There, what is the type of soil? Based on the type of the soil, you want your actuator, you want something to act differently. Then like other chemical content. Likewise, we have mechanical energy. There we can have your position and pressure. Now in this particular case, we can have your muscles movement, your cardiovascular pressure. The doctor measures the pressure and says or that state on what is the status of your health. Then we have your electrical energy. There we have for your EG, EMG and ECG. These are just a notation. These are just for illustrative purposes. So like EG, here basically my box is in EG area. So here basically we record your voltages. Now from what area we are recording? We are recording from your brain. So obviously in this particular case, we may have your we may have to insert electrode, or there could be a case that we'll be putting this electrode on a scalp itself. Obviously we'll be putting it on a scalp itself. Now there we have your skeleton. What does it mean? It means it is going to offer a very high resistance. So if it offers a very high resistance, obviously in that particular case your voltages will be very less. Rather it is in the range of your microvolt. Now your devices that you are using, it will have a tolerance of millivolt. Now you want to record a signal which is in the range of microvolt. So how can you deal this? So for this we need bioamplifier. Those who are from electronics background will understand that we have your op-amp here, which in turn can solve it. So in this particular case, we can amplify the signal. So say 10 to the power 6 times. So this allows to record such signal and at the same time analyze it. So likewise, we have your thermal for your body temperature. That still you can use. So this is highlighted. Now these values, we say nature and signature of bioelectric signal. What are these? So in this particular case, some frequency ranges, and then your, in case of dynamic range, what we call as your voltages. Okay. So in this particular case, like for basically your EG signal we are considering, there we have your, it is the different ranges are given. We are including some other artifact signal also, which in general get mixed with your EG signal. So there you can say, you can see your the signal range has been divided as, or that has been classified as delta, theta, alpha, and beta. It can be gamma also. Okay, more than 30 hertz, if I say, or in range of your 100 hertz, or even more than that, we classify that particular thing as a gamma. As per my interest, so we have classified from 0.5 to 30 hertz. So you can look at this thing, like looking at your EEG signal, like something, your signal recorded from your brain, you can find the status of your brain, status of your mood also, whether you are in happy mode or you are in stress mode, and at the same time your dodginess level also, if you are drunken. So right now what is being done is, like, they check the pH value. They'll ask you, like they'll put just before your mouth, and from there the change in pH, so that in turns determine whether you have taken alcohol or not. Now here the same thing can be done with the help of like analyzing your EEG signal as well. Now here we are explaining one Nobel Prize winning model, which is for excitation model, just to give you insight of this particular thing, from where we are getting those values. So here, so what exactly we have, like in our membrane we have ions. Just change of these ions will let your signal getting generated. So this in turn is a area of your evoke potential. So those who are from biomedical signal will understand it better. I just want you people to get insight of it. And the person who discovered it, the two person, I don't remember their name right now. The reason being they are not Indian, so their names are also very difficult one. Hudge Huxley model something. So they have been awarded Nobel Prize for it. Now, so here we are considering just one case where we need to have your recording paradigm. So we have just one case here where number of subject is 9. Number of subject, we say like a particular person. Like we go for recording. So here, like recording of 9 people has been considered, and the Q duration being like we define a Q. We ask a person to think, like thinking of moving hand. So what you people can do is, like if you put your one hand just above your head and another beside your stomach, and try to turn it in different direction, one in right direction, one in anti-clockwise direction, another in clockwise direction. Please try it and check if you are able to do it. एक को anti-clockwise घुमाना है, दूसरे को clockwise घुमाना है. You please try to do it and let me know if you are able to do it. No, you won't be able to do it. This is not possible. This is not possible. Why? Your brain orders it. If you're moving your hand, you're moving your limbs. So in that particular case, like your command has to be from your brain. Now in this particular case, your right hand is being controlled by left part of your brain, and the left part is being controlled by right part of your brain. This is like a knowledge. This is just an information. So using this information, like people can know whether the people is thinking to move right hand or left hand. That was my task. Getting it? So based on, like if you're sitting before something and you want, you're having coffee and at the same time you're having tea. So whether you want to have a coffee or tea and you want your machine to work, like your hands are not working. You can think, but that is not being translated into action. So you want some machine to translate that thought into action. So that's the area of BCI. Anyway, so here we have like recording a signal, you can understand. I'll have to skip this thing because if you are like acquainted with the thing, you'll understand. Otherwise, it's difficult to understand. Now, so what I want to explain is, in this particular case, like we have your electrode placement. We want to record some signal. From where we will record? So we have a very defined area. It means there is a special, at the same time there are temporal resolution which need to be checked. So here, so in this particular case, like for your ICs, there we have a notch. Here in this particular case, we have anion and Nassian. This side you will find a notch, and here your nose. So that is another point. So you need to join it. This is what we used to do. And then your earlobes will be joining it. So this way, we'll join it, and then we'll find what is the measurement. Best of the measurement will be placing your electrodes. In this particular case, basically we use 10 to 20 system electrode placement method. There are others as well. So based on that, on 10% of it, like we'll mark it. Another, again we'll join, and again we'll be repeating the same thing, and that's how like your electrodes are being placed on your scalp. Okay, now the problem that we are thinking about, like your limb motion, so that is called your motor region. So your motor region is one which connects your two earlobes. It means if I have to place electrode, so we need to place electrode in this region for this particular case. So here your lobes and its functions are given. So if you must be acquainted, we have frontal lobe, temporal lobe, central lobe, something that I was discussing, which is for your planning, control, execution of voluntary motor function. Then your parietal lobe, occipital lobe, like where to place the electrode. The placement of electrode is also important. We are recording a signal that for your biomedical applications. So in this particular case, we need to record the signal. So from where to record, it means your localization is also important. ऐसा नहीं है कि बुखार चेक करने के लिए कहीं से भी डॉक्टर मेजर कर रहा है टेम्परेचर, है ना. So here we have one recording setup here. Rather, he's my batchmate only. Right now, he's doctor. And then we have here, like, this is ID that we use to record it. Like, it will show you the platform and all. So we go for marking, the help of this. Like, we'll be operating on signal. So when we operate on signal, what part of signal we need to have? Should we take the whole signal in one go? No, we cannot take the whole signal in one go. There are a lot many reasons for it. So here we use your signal condition. Like pre-processings are being used. We need to group that signal. We need to remove your like your, we may have your line noises since this is being recorded. So sorry,
Doctor will say sorry.
Doctor will not say sorry because you cannot record signal for someone who have some disease. You need some very strict permission for it. There, like ethical things are also involved. So this is just formatting your signal vector. So like what is your sampling frequency, that in turn will determine what is my epoch length, like for what duration the signal was recorded. Now we do not record signal for any frequency, like we use sampling frequency. So from where we'll be getting it? You people have studied your Shannon sampling theorem. Of course we make use of it, but in practical way. Instead of more than twice, we make use of more than 5 times or maybe more than that. And then for how many trial is recorded, how many runs it had. So based on that, we make your signal vector. So in this, obviously, anything? So anyway, so in this particular case, we need, and from there, we have a recorded signal, we have pre-processed it. So obviously, what we would be doing is we'll extract your feature. So in this particular case, your WVD feature has been focused, Wigner-Wille decomposition. These are your time frequency distribution. So these are different features which has been used for this purpose. WVD is explained in a bit more detail. Now feature selection, how to select the feature. This is very important thing which I find students make mistakes. So we have a different way of finding your feature that can be classified as a time domain, frequency domain, and time and frequency domain both. So here, let me skip it. Here I'm just showing one example. So like energy, if I take energy as a feature, so this is the formula that we have. Getting it? So here in this particular case, what is done is we obtained a signal, and using the formula, like we found something, this one. Is it correct? It is not meaningful representation. Why? We have taken the whole signal. We have taken the whole signal. In this particular case, what we have, like, it should be the representation of certain thing, the whole, that lot. And if you're using the whole thing, obviously it makes no sense. Obviously, in this particular case, so your features should be representation of it. It should represent the whole signal. Here you may require lot many features there. That could be a case, but you cannot put the whole signal there. So what we have, the tailoring of the signal. So what we do is we break down those, the whole signal. What we'll be doing is we'll cut a part of it. So that's called tailoring of the signal. This is a very important concept. So, and from there, for each one, we'll be finding what features we are getting. We'll be using whatever features technique that you are applying, you'll be applying feature technique for that particular. There are a lot many things. Like if you're using FFT, to use your FFT, your signal should be a stationary one. Whether that is stationary. So when we are deciding this epoch length, when we are deciding this Q length, this should be as per that particular thing. And from there, we'll find this real-time problem which has been done. Now another one, this is just example. This is just example. It's not like for this particular case, your zero crossing feature has been used. It's not used. You know, this is just to explain this particular. Zero crossing is also a feature. So in this particular case, what we have, the moment it will cross a zero, it means what? You can know what is the frequency information. You can have it from here. So this is the formula that we have. Like for one task, for this particular task only, you can find what information your zero crossing may have. Like here, at this instance, you'll find the zero crossing is less as compared to the another reason. So obviously, in this particular case, like whatever biological interpretation is there, we can deduce from there. This is one such example. And then here I'm showing for another case, like you are posed to some easy task. Like in mathematics only, some easy mathematical computation is given, and then your signal is being recorded. Another moment will give you some difficult problem, and then you are solving it. And at that time, your signal is being recorded. So from there, like your result has been represented over here for your zero crossing. You know. So for different things, different methods can work much better. So this is just for frequency domain technique classification. Here we need to look at what are the type, what are the different type. We look at what features, what like what property a particular classifier is, and based on it, we'll be selecting for what type of problem. So let me skip this part. Choice of classifier means. So if we say EG signal, so EG signal is inherently that is a noisy. There will have your dimension would be very high. It means we have lot many data. We need time information as well. At what moment a particular Q was done, a particular thought was there. So based on it, we'll be checking. So here with your one, the results has been shown. These are just then technique for supervised and supervised. Let me skip this part, and then here you have artificial neural network. You know, so I wanted you people to get back to the slide or the concept. How much time do I have? So we can have a tea break. How much after? Oh my God! Okay, no issue. ठीक नहीं, इतना बोलते बोलते कभी कभी आदमी थक जाता है, अब सुनते सुनते भी बोरिंग हो जाता है, कोई बात नहीं. So here we have like we are mixing your neural network and the fuzzy to make it adaptive. Certain things, some problem will be solved by your neural network, and some problem would be solved by your fuzzy logic. So we call this as an ANFIS method. One which is being shown here, there we are considering your linguistic hedges as well. We say very good. very, very good, like in linguistic variable only. So this is called your linguistic hedges, which is being considered here. So here in my problem, that was considered, which has been just so the comparison of classifier for mental task. It means easy or difficult. So for different classifier, the result has been shown. For this, like we'll be discussing, like which classifier should be used. So obviously, each classifier will have some properties. Based on it, we'll be deciding. You know, so there is. So that's it. No, we can learn something about your neural network. है ना? ठीक है, कुछ देर बाद ब्रेकअप ले लीजिए, then we learn a bit of it about your neural network. I have skipped something which is not like you'll feel boring. I have skipped that part. That is my work. You may not be interested. Getting it? You may not understand those things. So something that you can understand, I have like used that part only.
Will you explain common mistakes we do?
Sorry?
Will you explain again the common mistakes we do?
A common mistake we do. Of course, I'll explain that. But yeah, of course, I'll do.
For feature selection.
For feature selection. ये फजी वाला खुल गया था, इसी से बताते हैं, है ना? With a real time example. Okay. Like in one BTech student was preparing a paper. So there he had used time. For time, he had used the fuzzy logic, like fuzzy quantity. It can be. The time can be. But in certain cases, like against it, you'll have other variable. So obviously in that particular case, we cannot use fudgification for that one. This is one. Like when we are making any quantity fudgy, so obviously we should not do it as it is. मन में आया तो कर देंगे. No, it should have a meaning. Like those variable we want to have an independence of lot many considerations. We can consider the other values of it. So there we can make use of your we are going for fudgification. This is one. Another being firing. I'm not able to show like your firing of rules in case of fuzzy logic. Let me draw your block diagram as well. In case of fuzzy logic, here we may have someone use normalization. So we may have a normalization block. Here we have some input. Now with your, after normalizing it, here we may have some set value here. And then here we have your normalization block. We have issue in normalization as well. And then here we have your fudgification model. ऐसे गंदा सा लिख देता हूं मैं. We have fudgification model. And then here we have got your inference engine. We call it FIS, fuzzy inference system, which in turn make use of your database. We have your rule base. And then from here we'll be getting some output, we'll be getting some decision. So again, that decision would be fudgified. But you want your actuator to work. You want, so your in general actuator, like you want your motors to get operated. So obviously it will understand some definite value, either 0 or 1. Getting it? So again, we need a very defined value. It should not be fudgified. We should not have ambiguity that those would be a certain values. So in this particular case, we have another model as say defudgification model. And from there, we are getting your output. Again, this is being fed. Here you may have a sensor. Those who are from control system, let me use in this way. So here before this, let me place another one. This is your plant. This is your plant, which is g of s. If we make use of a controller in that particular case, and then here, sorry, this is g of s. This is your plant, and this is your defudgification model. Getting it? Now, in this particular case, if there is an overlap of less than 52%, it means while making your fudgification rules there itself, if the cases are such this, like this, another being, say, if I have like this one. So in this particular case, only this range of value shows your ambiguity. Only this range of value, rather we don't have here ambiguity at all. So in this particular case, the rule base or the rule will not get fired at all. This is one thing. Now, you ask in general, like features, for the features. Here also, like we'll be having values, and from values we'll be getting your features. Now, suppose you make use, you're from electronics department, that's why I'm using, like if you have a very fewer number of points, and then you are using your FFT, obviously in that particular case, again you will get a wrong data. Then you are using a technique. Say there you might have used your STFT or say wavelet technique. Instead of using those techniques, if you are using FFT, for FFT the signal need to be stationary. Now, if your signal is not stationary, by stationary I mean the component of, like what component of frequency that we have. Getting it? So obviously in that particular case, if you are selecting a wrong method, you'll get a wrong answer. This is one. Now, if you're selecting lot many features, here we have feature reduction also in feature itself. Like in that particular case, your classifier will become very heavy. Like it will take lot many time. So there we have your feature reduction also. Let me give you a real time answer. You want to select a girl for marriage or matching, your what you call marriage matching. Now, there your criteria could be the girl should be her skin color, like her complexion. Now, there if you go on checking color of lot many areas, it may not work. This is the one thing. Other, you will check the color of just one area. Again, you may go wrong. This happened with me. Anyway, in light mode, this is light mode, otherwise I'm against of it. So what I mean to say is, like your feature selection is very important. And there we have feature reduction technique as well. You need to reduce the features. Getting it? Anyway, you're getting me in wrong way. I understand. Let it be. Anything else? ठीक है, इसी पे क्लोज कर देते हैं. What you I can ask you people to do something. अभी तो 2 बज भी गया, 2:25 में खत्म करना है, ठीक है ना? So if I'll take or neural network, if you want to explain, so I can explain bit of it. कर ही देते हैं, नहीं तो बोलोगे कि नहीं किया है. न्यूरल नेटवर्क कर दिया. न्यूरल नेटवर्क. न्यूरल नेटवर्क में बहुत फिर यूनिफिकेशन तो ऑलरेडी आई हैव ऑलरेडी कवर्ड. Defudgification you want? Huh? Defudgification. Again, the defudgification topic would be lengthy one. No, sir. उससे बेटर कि आपको outlines of neural network बता दे रहे हैं, है ना? So in one that you can see your MC Coulomb Pitts model is there, है ना? So that developed in 1943. जिसमें हम लोग अंग्रेजों को भगा रहे थे आसपास. So they were developing this particular thing, your neural network. This is the very foundation of it. So in this particular case, your weights are fixed. Your weights are fixed. So what we have, we are making decision. We are learning whether the things are correct or things are wrong. So to explain this particular case, like we make use of your AND gate, NOT gate, and all those things. Getting it? So there we make a decision making we are having, but your weights are not being updated. The next one is your Hebb network. So let me we can explain this particular more. So suppose we want to classify, we have two pattern. उस पर टाइम देंगे ज़्यादा लग जाएगा. So let me skip this one and get me to this one, like your Hebb learning. And from there, we have the extension would be your back propagation. So say your pattern is this one. I. This represents I. And another one say O or 0, whatever that can be called. Suppose we have these two patterns and we want to model it. Getting it? We want to develop model for it, or like in this particular case, with the help of this one, we usually teach Hebb rule or Hebb learning rule. So in this particular case, what we have, like here it is 3 cross 3 matrix. It can be anything. For simplicity, we are taking this one. So here we have 3 cross 3. So my inputs are this. I can mark it as x1. This I can mark as x2, x3, x4, x5, s6, x7, x8, and x9. Here also we'll have your x1, x2, x3, x4, x5, x6, x7, x8, and x9. So in neural network, what exactly we are doing? We are matching your input and target. And from there, we want to deduce what the system would be. It's one other way of like curve fitting techniques, if you look at. So what we can have is your x1, x2, x3, x4, x5, x6, दिख रहा है ना? x7, x8, x9. Another being your bias. So in your like MC Coulomb model itself, we explain that we have your input. With the help of input, if it crosses a particular threshold value, then your rules will get fired. Then you will have your output as 1. Getting it? Now in this particular case, so that threshold we are considering that as a bias. So here in this particular case, your bias, and then here we have weight. When we say weight, it means what importance should be given to a particular input. So what we have, like in any of the cases, we have your xi, wi. If you consider this one, so and then we have your theta. Now this theta, if this crosses like your y in, if you say, and then function of this, so whether this value should be 1 or 0, it depends. Like, or better to write -1 here. If we take that particular thing that side, so whether the rules will get fired or not, either it will get fired or it will not get fired. Now the case that we have considered in this particular case, so here the value is either there we have a value or we don't have a value. It means you can take this sign as like either we have a cross or whatever sign that it means there we have a value. Those are lit on. That's it. So we can take that value as like we can have a 1 or we can have a -1. Just for the distinction, we are making use of your bipolar. Getting it? So what we can do is like in this case, and bias being 1, it means what weight we should give. So in this case, we'll have 1 here. So we have x4 and x5. So these would be -1. Other values will be 1. Is this clear? So x4 will have -1. X6 will have -1. Other values are 1, 1, 1, 1, 1. And then your output value as y. So, or you can say target.
Example of image processing or
Any processing, right? Image processing. You can think of image processing where we have a 2-dimensional data. So here matching. So any pattern matching. Getting it? So in this particular case, with the help of your head network, what we'll be having is like here, it requires a lot many computation. The one this is for I, no? This is for I, another wing for 0. So we can have your inputs defined there. So in this particular case, like x5 is -1. Other values are 1. Other values are 1. Then this is another class. So another class, we'll mark it as 1. Now what we would be doing is like, what is your, here we need to update your weights. So in this particular case, what we have, your weight will be keep on changing. So when I say weight will change, it means there is a learning. Weight will, in initial case, the weight was fixed. It means you're making decision, but you're not learning. You're not updating. In another, the extension of what we have, we are learning, but we are learning a wrong thing. No one is correcting. We have a teacher. It means what? We can evaluate, we can find the error. We have a target, and we have the value that you are getting. So difference of it. So in back propagation, we can do it like, there are a lot many videos available, or here also we'll have, this is for, if I want to have like delta rule, Heb rule, another one, back propagation के लिए MTech student को कराए थे. So you'll have all this thing. So this is very lengthy way, and there itself, if I'll go on increasing the layers, so in that particular case, that will become deep learning. That will give you insight of deep learning. So there, what we have, it means there we have like we are correcting also. So first we have a decision, that is your MC Coulomb model or the neuron model. Another one, when we say head learning rule, so there what we have, we are updating your weights, we are learning. So that's how your like human learning works, and you want your machine to imitate that. So in that particular case, what we have, like we want certain parameters should get, we want some adaptive thing. So what it is, it should change itself. So there should be a correction in it. It's a continuous process. It will keep on evaluating. It will keep on checking with some fixed value, a target value. So there we have error correction. इसमें नहीं दिया हुआ यार, फोटो खींच रहा है. This is another problem. This one, there are issues with it, so this cannot be covered in just one go. Here, ANFI system is covered. Maybe there are fuzzy relation and all, like while designing your fuzzy controller, not the one thing which need to be covered. So it cannot be covered just in 2 hours. And then there is a variation of it, like there you people must have studied RBF. बहुत देखो जो neural network पे starting में काम करना start किया है. So what exactly it is? You have some difference, say 0.3, another being 0.5. Now the difference is of 0.2 only. So how can we increase it? It means changing one dimension to another dimension. If you use some mathematics operation, उसमें e to the power x लगा दिया, obviously your like separation will change. So that will become another method. Like in my case, whenever you will be using your neural network, so there itself we will be having your optimization technique also included. You change one parameter of optimization technique, and that may account for a better result and another method as well. I thought that I'll like illustrate some problem, but somehow my system is not working. I don't want to give an excuse, but it's okay. That's all. Anything from your end? Or I can close the session here itself. Yes, 25 मिनट पहले खाना खाएंगे यार.
Thank you, sir, for the wonderful lecture. The online participants, are you having any question?
Thank you so much, sir.
Thank you so much, sir, for the energetic lecture. And
Thank you.
now the lunch break is there. We will assemble here again at 3:15 for the next lecture.
Sir,
One question is no.
Sir,
This is
please
from
give this.
this is from previous lecture. So okay, everyone can leave. We will start the next session at 3:15. Okay. Now the lunch break is there.
You can use advanced method like PNN, RNN transformers. They are like my recent work. My PhD student is using transformers.